All right, hey guys, I just wanted to do a couple more examples from 7.5. So I know we did quite a few in class, and I actually can't quite remember the exact ones we did in class. So kind of bear with me if I end up doing one we already did in class. But I want to do about 3 more for you, maybe 4 more, so you can kind of see other examples of some other examples of equations. So let's solve let's do the given interval 0 to 360. Okay, and I wanted to do one like this because this one can be a little bit weird. So I have 1/2 cosine of theta plus 1 equals 1.2108. That's going to be the first one that we'll kind of look at finding the solution of. So I want all solutions that, from 0 to 360 like we talked before. So I'm going to subtract 1. So I get 1/2 cosine of theta equals 0.2108. And then I'm going to multiply both sides by 2 because I want to get that cosine of theta by itself. Okay, so grab my calculator here, 0.2108 times 2. So I get 0. Well, I probably could have done that in my head, but all right. So this one's a little bit different than the ones we did in class because before we had cosine of theta equals 1/2 or cosine of theta equals √3/2, and they were actual values that we know what theta is. So look at what this is saying. I want all angles whose cosine is 0.4216. Where is cosine positive? Because this is positive. So I want all angles in quadrant 1 and 4 where theta, the cosine of it, is 0.4216. So the trick with one like this is to take the inverse cosine of both sides. Now the problem with that, there's not a problem with it, but kind of the issue with that is we are going to have to actually do a little bit more work because remember, where is cosine theta going to spit this guy out? This guy is only going to be in quadrant 1. So what this gives us then is this gives us the reference angle for theta, and then we can find the other angle in quadrant 4. So I'm just going to do cosine inverse, making sure my calculator is in degrees of 0.4216. I put cosine of it. How about cosine inverse? All right, and so what I get is I get theta to be 65.06 degrees. So that's this angle right here. That's one value for theta. Well, the other angle that will satisfy this equation then is the angle, right, whose reference angle is also 65.06 in the 4th quadrant because we want cosine to be positive. And I'll be positive in the fourth quadrant then, right? I don't know what I was just saying. If I'm in the 4th quadrant, I'm positive. So I'm going to take 360 minus 65.06. That's going to give me my other angle. Because remember, cosine inverse won't give you both angles because cosine inverse is a function. And so a function won't do that. It'll just give you one angle. So my angles are 65.06 and 294.94 degrees. And if you put these two angles in your calculator, you take the cosine of each one, you'll see that you're going to get 0.4216. And of course, if it asks for all solutions, you would put plus 360k, right, to both of those. All right, cool. Let's do another one. So I want to show you one example like that where maybe you don't know the actual angle and you need to use inverse cosine to do it. How about one like this? And we'll solve this on 0 to 2 pi. So the trick here with something like this, you might want to change it into sine cosine, but I actually wouldn't do that because we're going to get fractions. So the trick here is to actually subtract. I guess you could turn it into sine cosine, but I think, let me show you, this will be easier. I'm going to subtract tangent of x from both sides. And then what I notice is what do we have that is common in both terms? I have a tangent of x that's common. So what I'm going to do is I'm actually going to factor out tangent of x from, why did I put an extra parenthesis? I have no idea. I'm going to factor out a tangent of x from each term. So I'm left with 2 cosine squared of x, so I know that's going to equal 0. Anytime I have two things set equal to 0, I set them both equal to 0. So here I have a little bit of work to do. I'm going to add the 1 and divide by 2. And then when I take the square root, remember anytime we bring in a square root, we need a plus and minus. So I get plus or minus the square root of 1 over 2. Over here, where is tangent 0? So remember tangent is y over x. So tangent is going to be 0 wherever y is 0. So that's on the y-axis. So when x, oh, shoot, what did I just do? Oh my goodness. You're probably yelling at me there, yelling at the computer. That's fine. All right, so where is this 0? It'll be pi over 2 and 3 pi over 2. That's simple enough. So there are 2 of my solutions there for x on the interval 0 to 2 pi. And then cosine here, so if I look at cosine of x being a positive 1 over root 2, well, where's cosine positive? Again, that's 1 and 4. And then cosine of x being a negative 1 over root 2. Cosine's negative in 2 and 3, okay? So where is it positive? Pi over 4 and 7 pi over 4. My reference angle is 45 degrees. And then where is it negative? We're going to have 3 pi over 4 and 5 pi over 4. So we basically get every angle between 0 and 2 pi with reference angle pi over 4. And so there are all of my solutions. I hope that makes sense. Okay, I want to do 2 more, and then we'll be done with this section. Whoops. What about one like this? Let's do 10 sine squared x minus 12 sine x minus 7 equals 0 over the interval 0 to 360. Okay. Okay, so for this one, I am actually going to do a substitution here. I'm going to let m equal sine of x, okay? So I would get 10m squared minus 12m minus 7 equals 0. And unfortunately, we can't factor this. You can try. It won't work. Try and factor it. So if I can't factor this, I'm going to be using the quadratic formula. So quadratic formula, opposite of b, plus or minus the square root of b squared, which is 144, minus 4 times a times c all over 2a. So I want to do one like this because I think I gave you one where it doesn't factor. Of course I gave you one where it doesn't factor on the homework. So I'm just throwing this into my calculator. So m equals 12 plus or minus the square root of 424 all over 20. So the reason I didn't worry about the sine of x here is because I knew this wasn't going to factor. So let me put this into my calculator. I'm going to do 12 plus the square root of 424 divided by 20. And I'm going to carry this out pretty far. 1.629563, especially if I'm working with my math lab. I want to go out pretty far to make sure that I get my rounding correct. And then I'm going to put in 12 minus root blah, 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 and I get a negative 0.429563. So there's all my side work. Now, what did I let m be? I let m be sine. So I want to look at, let's look at this first one. Sine equals 1.629563. So I'm going to do what that very first example I showed you. I'm going to try something like this, where I take the inverse sine. And I hope this is making you uncomfortable. It should, because if you take the inverse sine of a number bigger than 1, your calculator is going to freak out. And I want you to remember why that's true. That's true because remember the domain of sine inverse is negative 1 to 1. So this does not exist. So I know that this is not a possible solution. Okay, so I look at my other option. Sine of x equals negative 0.429563. I think this one will be a winner. So I put sine inverse in. If you guys are falling asleep, wake up. I was just thinking of Hunter telling me he falls asleep and or zones out. Don't do that. How could you zone out on this stuff? It's so interesting. So take sine inverse of a negative 0.429, well, to me anyway, 563. There are other people out there too, I'll have you know, at my math conference. People that care about this. Now, here's what's going to be a little bit tricky about this. So what do I get? I get x to be a negative 25.398. So let's do 0.44. Now, this angle right here does not lie between 0 and 360. Obviously, it's negative. But what this does for us is it gives us a reference angle. So let's think about where sine is negative. So I want my answer here and here, right? So what I need to find is I need to find an angle with reference angle 25.44 in the third quadrant. And I need to find an angle with reference angle 25.4. I don't know if you can see that. That might not have done any good. 25.44 in the fourth quadrant, right? Because this is my reference angle because that just drops it into the fourth quadrant. So for the purple angle, I'm going to take 180 plus 25.44. And I probably didn't need my calculator for that, but sometimes I really don't trust my arithmetic skills. Okay, and now I'm going to take 360 minus 25.44, and I get 334.56. I hope that makes sense why I had to do that, okay? Why I had to rewrite that with the 25.44. Okay, and you can of course take the sign of that and see that that is true. All right, I just want to do one more example. Did I say that was my last one? I don't think I said that was my last one. Let me clear this. Whoops, sorry about that. Get so mad at me sometimes. All right, one more, last one. This one maybe will be a little easier. Let's try it. Tangent squared of x plus secant of x minus 1 equals 0 from 0 to 2 pi. Okay, so the first thing I want to do is I need to get this all in terms of one function because I can't like factor out a secant or factor out a tangent like I could with that. Whoa. Sorry about that. Like I could with the one with cosine and tangent. So what I want to do here is I notice I have a tangent squared x, and I think to myself, I know that tangent squared plus 1 is secant squared from my Pythagorean identity. And how could I rewrite tangent squared then in terms of secant? I could make it secant squared minus 1. Okay, so what do I get? I get secant squared x minus 1. Now I'm going to rewrite the rest of this. Plus secant x minus 1 equals 0. Combine like terms here and I get secant squared plus secant minus 2 equals 0. This sucker's going to factor. It should factor into secant x, not just should, it will. A 2 and a 1. I want the 1 to be positive, so I'm going to put the negative with the 1 and the positive with the 2. All right, so we have two equations to solve. Where is secant equal to 1? And where is secant equal to negative 2? If I flip both sides, that tells me where is cosine equal to 1 over 1, which is also known as 1. And where is cosine equal to a negative 1/2? So where is cosine equal to 1 between 0 and 2 pi? At 0, right? Because cosine are your x values. Where's cosine equal to negative 1/2? Well, I know I want to be in the quadrant 2 and 3. That's where cosine is negative. My first angle, I want this guy, right, with a reference angle of 60 degrees. That doesn't look like 60 degrees, but you'll forgive me, I think. Maybe not. Maybe you won't forgive me for not writing this perfectly. Well, I'll probably move on. So, all right. So what do we have for x then? 60, remember, is pi over 3. Because it says 2 pi, so it doesn't want this in degrees. So pi over 3, I'm pi over 3 away from 3 pi over 3. And then I'm at pi over 3 more than 3 pi over 3. So there are my other two solutions. That's it, my friends. I hope that makes sense. I hope that helps you with your homework. Make sure you do the fun sheet for this section, as always, and I will be sending you a take-home quiz for this section as also. All right.